Hello everyone, welcome to my channel. We are going to understand a complete firefighting pump system and we will discuss from basic to advanced. So in this video lecture, we will cover working of each component, pump operation sequence, pressure logic, technical aspects, market alternatives, what are the alternatives available in the market for this type of design, and some interview level question and answer. So we will start from here. So here at the top we have two fire water tank with capacity 38,000 each, and these tanks supply water to suction header, that is here. So this is the suction header, this is the suction header pipeline, and this suction header feeds the water to the pump. So this suction header feed the water to the pump, and the pump includes, this one is main fire pump 1, this one main fire pump 2, that is we also called a standby, and the third one is jockey pump. So these three pumps are available with this design, and after that all these three discharge water into delivery section, delivery header, that is here. So all these pump discharge water to this delivery header, and after this delivery header supply the water to the hydrant test line. So these are the hydrant test line, and the station network, that is here. So this is the how water flow from fire tank to a station. From here water will reach to FSC, and during fire case we will utilize that water. Now we will discuss each component in detail. So just erase these all things and we will look each component one by one. So this one is the primary source of water, this is fire tank, primary source of water, either filled by borewell pump, borewell, or municipality. Here we are taking from IMC. So water source are from borewell either or IMC. Second one is after fire tank valve. So it is either full open valve or fully closed. It provide very low frictional losses, very low frictional losses. And we will rotate this valve, actually move either upward or downward, so it provide the frictionless get to the water flow. So that's why we get a very low frictional losses here. Now next one is a strainer, this one is a strainer or wire strainer. So it basically remove dust or debris which are coming from the fire tank, come from fire tank. So after doing this, it basically protect impeller from damage or choking. It also reduce the chances of cavitation due to clean flow. So these all are the characteristic of strainer. We have already discussed sluice valve. Now we will discuss expansion bellow. So expansion bellow is installed in a piping system to observe the thermal expansion, thermal contraction, vibration, or slight misalignment of the pipeline. Actually, whenever water flow in the pipe, or when pump start or stop, the temperature of the pipe increases. Due to this, the pipe naturally expand or contract. If this thermal movement is not observed, it may generate high stress on the pipe. Okay, so it generate a stress on the pipeline if we are not providing expansion bellow. So expansion bellow help in reducing the stress on joint, valve, pipe. So here we are writing what are the benefit of expansion bellow. Observe thermal expansion and contraction of pipe. दूसरा, reduce vibration which transmitted from the pipe, which transmitted from pump. 3. It protect flange, valve and pump casing from either vibration or stresses, excessive stress. Okay. 4. Compensate minor alignment inaccuracy during vibration. There might be the chances of minor alignment mismatch, so expansion below minimize that minor adjustment also. So compensate minor alignment. So by doing this, overall life of the firefighting pipe increases. So these all are the benefit while using expansion bellow. Next is so we have covered this as well. Now pressure gauge is basically measure pressure. Now we will discuss NRV. So basically NRV is non-redundant valve, and it allow water to flow in one direction, basically only in one direction. So it will not allow to either in one direction, so it will not allow water to flow in reverse direction. So prevent reverse flow of the water. So it will not allow to flow water from delivery header to pump. It also protect pump from water hammer and back pressure, and it also ensure the proper pressure maintained in delivery header. Maintain pressure in delivery header, and it automatically 5 is automatically close when flow is reversing. So auto close when water flow reverse direction. So these are the key point regarding NRV. Now next is butterfly bulb. So butterfly bulb used for isolation and throttling in a large diameter for fire pipe. So it basically इसको बोलते हैं क्विक क्वार्टर टर्न ऑपरेशन बेसिकली 0 डिग्री टू 90 डिग्री इसका ऑपरेशन सीक्वेंस है और इसमें लो प्रेशर ड्रॉप होता है ड्यू टू इट्स डिजाइन and also cost effective as compared to gate valve, cost effective as compared to gate valve. It commonly used valve. Now we will discuss main fire pump. So it basically main fire pump. So there are few points which you need to keep in mind. So it is basically discharge rate is basically 283 liter per minute. So it will basically discharge this much amount of water in 1 minute, and total head is 75 meter. So it will flow water up to 25 meter height or maintain constant pressure up to 75 meter horizontal pipe. There is a motor rating around 48 HP. So these are the specification for main fire pump that applicable for as well standby. And now we will discuss jockey pump. So jockey pump discharge rate is 180 liter per minute, and total head is 75 meter and cut-in pressure is 6 kg per centimeter square, and cutout pressure where pump motor will stop 7 kg per centimeter square. Here motor will turn on and here motor will off, pump will off, and the cut-in pressure here is 5 kg per centimeter square, and there is no cutout pressure because it will manually off and auto start. So there is cut-in pressure, and this pump, jockey pump, is auto start, auto off. So these are all the technical details. Now here is pressure vessel we are using for it basically maintain pressure stability in the system. Second one is it also reduce the frequent start and stop of the jockey pump or main hydrant pump. So stop frequent operation of the pump. So basically it observe a small pressure fluctuation. So it basically provide air cushioning. So these are the all points regarding pressure vessel. Here we are using 3 pressure gauge, one for jockey, one for main hydrant 1, and this one for main hydrant 2. So we are actually giving signal of the pressure established in delivery pump from here, and based on the pressure our pump will start. So these are the, we will next video we will discuss the sequence of operation of the pump. So in this video, this is the all we have discussed. In next video we will discuss the sequence of operation of the pump. Thank you.